Welcome back. In the last session, we had seen the AC parameters of the amplifier. Okay. Now, I rubbed the diagram, but if you go back, when we replace the BJT amplifier or BJT with respect to H parameter model, right? I told that this is HIE and this is HI and this is HR into V2 and this is HF into I1 and this is 1 by HO, right? This is what is the black box. This is what we used, and I want to tell one point here. Now, if you consider your BJT, we have 3 terminals. Let us say this is emitter. Emitter is common. If emitter is common, then instead of HI, we should take HIE, HRE, HFE, HOE. We need to add extra subscript, which is nothing but common emitter. Therefore, E, HIE, HRE, HFE, HOE. If base is common, let us say if base is common, then HIB, HRB, HFB, HOB. Or if collector is common, HIC, HRC, HFC, HOC. Whatever H parameter model we used or we got from two-port network analysis, remember this is generic, which we can use for any configuration, either common emitter, common base, common collector, but only the thing what we need to do is instead of taking HI, HIE, HRE, HFE, HOE, we need to take proper H parameters depending upon the configuration. Okay. That is one point. Therefore, then whatever formula we derived, let us say current gain, if you take current gain, right, generic definition is nothing but, generic formula is nothing but minus HF divided by 1 plus HOE into RL, right. Let us say if this is common emitter configuration, then it will become minus HFE divided by 1 plus HOE into RL. If that is common collector, minus HFC divided by 1 plus HOC into RL. But our job is to know what is the value of HFC and HOC or HFE, HOE depending upon the configuration, and substitute, we will get corresponding current gain. Therefore, whatever formulae we derived, those are generic and irrespective of the configuration, but we need to use proper H parameters to substitute and then get the values. I hope this is clear. Now, let's see the H parameter values for a typical transistor. No need to by heart the values what I give now. Just take them for the reference purpose, but the values will be given in the examination. Okay. Now, let me give you the CE H parameters. If you take, this is what is first one, CH parameters. HIE is equal to 1.1 kilo ohm. HFE is equal to 50 and HRE is equal to 2.5 into 10 to the power of minus 4. HOE is equal to 1 by 40 kilo ohm, or I can say 25 microampere per volt, the typical values. Okay. Number 2, maybe you can compare CC configuration. HIC is equal to, which is same as HIE is equal to 1.1 kilo ohm. Okay, and then HFC is equal to minus 1 plus HFE, and converting into CEH parameters and then giving you, then if you substitute, because if you know only CEH parameters and if you know the conversion formulae, then we can get CCH parameters also. But I'm saying no need to remember, but it's better if you remember the conversion formulae. Sometimes even the configuration is CC, but CEH parameters will be given. If CEH parameters are given, then if you know the conversion formulae, then we can get CCH parameters. Okay, that's fine. Minus 51. Then HRC, that is 1. HOC is equal to HOE is equal to 1 by 40 kilo ohm, which is 25 microampere per volt. Okay, similarly third one, CB amplifier or CB configuration, then HIB is equal to HIE divided by 1 plus HFE, which is basically 21 point something, approximately 22 ohm. Then HFB is equal to minus HFE divided by 1 plus HFE, it is minus 0.98, which is approximately equal to minus 1. Okay, that is fine. And HRB is equal to, I'm giving directly 2.9 into 10 to the power of minus 4, and HOB is equal to 1 by 2.01 mega ohm, which is 0.49 microampere per volt, or you can say approximately 0.5 microampere per volt. Okay, these values will be given in the examination, but not exactly these values, corresponding to the transistor, which is what is used practically. Maybe in the classroom or the workbook, whatever you are going to solve, even though if I don't specify, right, you can take these typical values and we can solve the problems. Okay, but if you take all previous GATE examination problems, I'm repeating this again and again, these values will be given. Okay, don't try to substitute these values even though they are given in the examination, then it is wrong. Okay, whatever it is given in the examination, that we need to use. Sometimes the H parameters will not be given directly, indirectly they will be given. Then we need to convert or try to extract from the given data to get H parameters, but don't use these values. Okay. These values we can use to solve our workbook problems. Okay. Write down, maybe you can refer to your workbook. Okay, problem number 1. Problem number 1. If you refer to the workbook problem number 1, asking for voltage gain. Okay. Now, if you see the problem, the circuit is given. We need to calculate what is voltage gain. Okay, and H parameter values are not given. Therefore, you can take the typical values whatever I have given before. We can use them and then we can solve the problem. Okay. Now, before solving the problem, let me give you the procedure. Okay. Then let's follow the procedure blindly. The procedure is to solve BJT problems. Okay. Procedure to solve BJT problems. Okay. Procedure is based on the problem statement. Let us say the circuit is given. The circuit is given in the examination. Okay. Based on the problem statement, classify the problem into either problem is related to AC analysis or DC analysis. Let us say now if you take this problem number 1, asking for voltage gain. Is it AC parameter or DC parameter? Definitely AC parameter, because voltage gain, current gain, input impedance, output impedance, wherever we are trying to deal with AC signals, obviously that is nothing but AC analysis. Let us say if I am asking what is operating point, what is output DC collector current, what is output DC voltage, what is the power consumption by the transistor, what is Q point stability, what is stability factor, right? These are all, and finding the value of a resistor. Therefore, these are all related to DC analysis. Okay. Therefore, based on the problem statement, we need to classify the problem into either based on the circuit and based on the problem statement, you need to classify the problem into AC analysis problem or DC analysis problem. Classify the problem into either AC analysis or DC analysis. After knowing the problem, saying that it is related to the AC analysis, then next step is find immediately AC circuit. Find immediately AC circuit. What do you mean by AC circuit? If there is an inductor, right, for AC analysis, your inductor will be acting as open circuit. You can treat it as open circuit. Even if it is offering some impedance or reactance, you can treat it as open circuit. Okay. And if there is a capacitor, short it. If there is a voltage source, short it. If there is a current source, open it. If there is a AC voltage source, keep it, because we want AC signals, right? And if there is a transistor, BJT, replace with H parameter model. Actually, we did already that replacing BJT with H parameter model, which is AC equivalent circuit, right? Then no need to replace, keep it, and then assuming that we are replacing and then we are using the formula what we derived. Okay. Now, after getting AC circuit, the next step is find the configuration. Find the configuration. What do you mean by configuration? Whether it is common emitter, common base, common collector. Because only when you know the configuration, then only whatever formula we derived, AI, AV, RI, R0, right, we can replace with like HI, HIE, HI, HR, HIC, HI, HIB, right? Therefore, we should know the configuration. After finding the configuration, right, just apply the formula. Apply the formula. Okay. Now, coming back to DC analysis. From DC analysis, after knowing that the problem is related to DC analysis, immediately find DC circuit. How will you find DC circuit? If there is a capacitor, for a DC capacitor acts as a open circuit. And if there is an inductor, for a DC inductor acts as a short circuit, right? If there is a voltage source, keep it, because that is a DC voltage source. If there is a current source, keep it. If there is a AC signal source, take it as 0, because the circuit, we are trying to get only DC point or DC operating point or DC quantity. We don't want to give the AC signals, even though AC signals are given in the problem statement or actual circuit. Then take out all AC signals, right? Only keep with DC circuit or DC signals, then you will get DC circuit. After knowing the DC circuit, just we need to apply KVL equations. Apply KVL equations, or apply KVL to get our KVL equations. Either input KVL, sometimes by applying only input KVL we can get the answer, or by applying only output KVL you will get the answer. Sometimes we need both. We need to apply both input KVL as well as output KVL and solve the equations. Solve the equations along with BJT DC current equation. Along with BJT DC current equation. What is BJT DC current equation? IC is equal to beta into IB plus 1 plus beta into IC naught. This is what is BJT DC equation, and this is not valid for AC analysis. This is valid only for DC analysis, and this is valid only when the transistor is in active region. Okay, that is fine. Typically the transistor circuits whatever will be given in the examination, they will be in active region, and if they are not in active region then it will be specified. If it is not specified, that is our job to check whether the transistor is in active region or not. Typically all will be in active region, else because we know the conditions with respect to VCE, VBE, right? If they are satisfied with respect to active region, then we can go ahead. Okay, when we solve the problems you will understand. Okay, take this procedure, let us apply this procedure to solve the problem. Okay, in the meanwhile let me write here what is the problem statement. We need to find the voltage gain AV is equal to V0 by Vi for the following circuit. Okay, the circuit is given. This is what is the circuit. Okay, first of all write this procedure, try to apply this procedure to solve the problem. Okay, maybe initially let me apply and then let's solve the problem. Maybe as we go on we need to apply this throughout our BJT amplifiers. Okay, wherever BJT is there we need to follow either AC analysis or DC analysis. Okay. Okay, now let's see the problem number 1. Let us apply the procedure. Okay, now tell me, asking for voltage gain, right? what is voltage gain for this amplifier? Is asking what is V0 by Vi, not V0 by Vs. Okay, asking core amplifier voltage gain. Now, first of all, tell me, based on the procedure, tell me whether the problem is related to AC analysis or DC analysis. Definitely AC analysis, because this is what is AC parameter, right? If the problem is related to AC analysis, then what we need to get? We need to get AC circuit. Okay, therefore what is AC circuit? If you take AC circuit, right, I told you, transistor, we need to replace with H parameter model, but we already did it and then we got the formula, therefore no need to do that, assuming that it is replaced. And resistor is as it is, it won't change with frequency, and RS is equal to 1 kilo ohm, and the input voltage source, that also we need to keep, because this is AC signal, and this is what is your input signal, Vi, and this is connected to ground. Now, let's see, what about the power supply? This is nothing but, what is the meaning of saying that the voltage at this point with respect to ground is nothing but 10 volts. Therefore, there is a battery connected between this node to ground. If there is a battery which is what is connected between this point to ground, then maybe for your understanding, I can say this is what is connected to. Therefore, this is what is connected to ground. Instead of representing like this, normally people say the node voltage with respect to ground. By default, if a node voltage is specified, the reference is ground only. Therefore, this is what your VCC, right? This is what is given. And I told that for AC circuit, then tell me what is change in VCC, because we need to take everything change in quantity. Change in voltage, yes, that is present. Change in resistance, right? The dynamic resistance, that is nothing but 1K. The dynamic circuit of BJT, H parameter model, the dynamic circuit of your power supply. Therefore, we need to replace everything with its internal resistance as dynamic resistance. Therefore, the dynamic resistance of your VCC is equal to 0, because what is change in VCC? This is nothing but normally for DC, therefore change in VCC is not there. That is what is equal to 0. Therefore, this is what people call it as AC ground. This is what is called AC ground, because for AC analysis, this is what is shorted to ground. If that is what is connected to ground, then what you get? Then the circuit will become. This is RS, which is what is 1 kilo ohm. This is Vs and the input voltage, right? Now, this is what is the load. It is connected. Let us say this is what your RC, you can treat it as load actually. That is what is your 10 kilo ohm, and this is what your V0. This is collector, emitter, and then base. Now, this is what is your AC circuit, and this is what is our AC ground. Your power supply is connected to ground, but remember, physically it is not shorted to ground. Physically, if you short it to ground, there is no DC power. If there is no DC power, we will not get any amplification, because what is the definition of amplifier? Amplifier is a circuit which converts DC power into AC power under the guidance of input AC signal, right? Then if you short it, then there is no DC power, therefore no. This is for our understanding purpose. We are taking out the DC quantities which are not required to solve or to get the voltage gain, which is output peak to peak divided by input peak to peak. Therefore, we are speaking about only AC signals, not the DC signals, right? Therefore, this is only AC circuit. Now tell me, what is next step? We got AC circuit, and this is what is our black box, right? This is what we used while solving the while deriving the AC parameters. Therefore, this is what your BJT amplifier, and input is given, load is there, output is there, input is there. Now asking for voltage gain, right? And we know the formula. Substitute the formula and then use the typical values of H parameter, then we will get the answer. Therefore, what is the next step? The next step is find the configuration. Now we need to find the configuration. What is this configuration? Where are we applying the input voltage? We are applying the input voltage at the base with respect to ground. Emitter is at ground. Taking output at collector with respect to ground. Emitter is at ground. Therefore, for both input and output, right, emitter is common. Therefore, this is common emitter amplifier. This is common emitter amplifier or CE amplifier. This is common emitter amplifier or CE amplifier, right? Then once you know the configuration, what is the next step? We need to apply the formula, what we did or what we have, then we can find voltage gain. I think we know it. Let's substitute and then get it. Let me erase this because I need board to solve the problem. Therefore, now to find voltage gain, or I can say we know that formula AV. What is voltage gain formula? If you go back and refer your notebook, you will see what is voltage gain. Voltage gain is equal to AI into RL divided by RI. Right? Here what is load value? Your RC is nothing but your load value, right? The output which is what is connected to, the effective load which is what is connected to your transistor output is nothing but 10 kilo ohm, right? And you know only RL. Do you know AI? No, we don't know. Therefore, let us call this as star. Now let us find AI. To find AI. What is AI? AI is equal to, because this is common emitter, I am just taking minus HFE divided by 1 plus HOE into RL. Then substitute, you will get the answer. What is HFE value? From typical value is 50 divided by 1 plus, what is HOE value? 1 by 40k, RL value 10k. This is what is 10k. Then if you substitute, kk will be cancelled, 10 by 40, 1 by 4, 1 plus 1 by 4, 5 by 4, 5 by 4 will become 4 by 5, 5 10 jar, 10 into 4, therefore you will get minus 40. This is what is your current gain. Right? Now we got to know current gain, now we need to calculate RI. To find RI, right? What is RI? We know that RI is equal to HIE plus AI into HRE into RL. This is what is our formula, right? Then substitute. What is HIE value? 1.1 kilo ohm. AI value minus 40. HRE value 2.5 into 10 to the power of minus 4. And RL value 10k. 10k is nothing but 10 to the power of 4. Therefore, 10 to the power of 4 into 10 to the power of minus 4, 10 to the power of 0, which is 1, 2.5 into 40, 25 into 4, 100 minus 100, 1100 minus 100, 1000, which is nothing but 1 kilo ohm. Right? Now, I think now we can solve the problem. Star implies, now we know everything to solve. Therefore, star implies, what is voltage gain? Voltage gain AV is equal to AI, which is nothing but minus 40, and RL, that is nothing but the load value 10 kilo ohm, and what is RI? That is 1 kilo ohm. Then kk will be cancelled, then this is minus 400. This is what is our voltage gain. Therefore, we got the answer. Therefore, what is voltage gain? Minus 400. I'll explain the meaning of minus. I can say problem is over. With this, problem is over. Maybe before proceeding to next problem, I want to explain or let us have some observations and let us have some conclusion. Then that will help you to solve the second problem, and then as we continue, we can have the link between one configuration to another configuration or one problem to another problem. Okay, that is very important. Linking is very important. Therefore, I can say problem is over. Now, let me explain a little bit theory about the common emitter amplifier. Right? Now, we got to know voltage gain, we got to know current gain, and we got to know input impedance, right? Now I think out of 4 we got already 3. Just to complete, let us calculate the 4th one, output impedance also. Now to find output impedance, problem is not there, but it is not there in the problem, but I am just calculating to explain some theory to find R0. What is R0? We know that Y0 is equal to HOE minus HRE into HFE divided by RS plus HIE. Okay. Now what is HOE? HOE is 25 microampere per volt minus HRE 2.5 into 10 to the power of minus 4, HFE 50 divided by RS 1 kilo ohm, HIE 1.1 kilo ohm, right? Then if you solve, what is this? Can I say this is nothing but 25 micro minus 2.5 into, right, 10 to the power of minus 4 into 50 divided by, can I write 1k plus 1.1k, which is 2.1k. Can I write 2.1k approximately 2k? If you don't want to have some approximation and then you use exactly and then calculate and then tell me what you get. But before that, you try to solve in that way. But let me solve the small approximation, then verify whether it is matching to your exact analysis or not. Okay, let's see. Therefore, let me say 2k. 2k means 2 into 10 to the power of 3. Therefore, tell me what is 10 to the power of 3. If that is going to numerator, 10 to the power of minus 7. If that is going to 10 for minus 7, then it is 0.1 micro. The 0.1 into 50, 5 divided by 2, 2.5 micro. 2.5 into 2.5, 6.25 micro. Therefore, it is approximately 25 micro minus 6.25 micro, which is nothing but 25 micro minus 6.25 micro, which is 18.75 micro ampere per volt. This is what is your Y0. Okay. Now let's see what is R0. Therefore, R0 is equal to 1 by Y0. Then what is that 1 by Y0? 1 by 18.75. 1 by 18.75. That micro will become mega ohm. What is 1 by 18.75? Let us say approximately 20. Then 1 by 20. 0.05 mega ohm, which is 50 kilo ohm. Definitely more than 50k. When you solve, you will get, therefore R0, you will get maybe approximately 52.5 kilo ohm. This is what is your R0. We can take these values as granted for a typical transistor. Remember, okay? That's why we need to solve practical problem with the practical H parameter values and the practical configuration. Okay? I think we got all 4 AC parameters related to common emitter amplifier, and current gain minus 40, input impedance 1 kilo ohm, voltage gain minus 400, output impedance 52.5 kilo ohm. I'll come back to Ri, which is 1k, R0 52.5k later. Now let me explain a little bit about current gain and voltage gain. Okay. Now before going to the magnitude part, let's see what is the meaning of minus. Okay. Why are we getting minus? If you remember, when we solve or when you take your amplifier configuration, we always took what? The current which is what is entering into the load is nothing but load current. That is what is our convention, right? That time I told, right? Therefore, this is nothing but your load, then this is nothing but your load current. With respect to this current only, we define your current again. The current which is what is entering into your amplifier, actually this is nothing but your I1, and the current which is what is entering into your load is nothing but IL. But if you see the real current flow is nothing but, actually this is what your collector current, and this is nothing but your base current, and this is nothing but your emitter current. These are all real current flows. Therefore, base current plus collector current is nothing but your emitter current. Therefore, your load current is opposite to real current flow. Your load current is opposite to real current flow, and your input current is same as your base current. Therefore, here your two-port network input current flow is same as the real current flow, which is IB. That is fine. But the two-port network current, which is what is nothing but I2, that is matching to real current flow. But with respect to load current, that is exactly opposite. But we took our gain, current gain, as IL divided by I1. But IL is negative, therefore we are getting negative current gain. saying that what is your IL? Your IL is equal to minus 40 times of your input current, that is nothing but your base current. Whatever current which is what is entering into your amplifier, 40 times of that current you are trying to pump into the load. But minus, meaning of minus is nothing but the current is not entering into the load. Actually the current is coming out of the load and then entering into transistor. That's why the meaning minus. Therefore minus is indicating only the direction, not anything else. Okay. No need to bother about it. If you take magnitude, which is mod A is equal to minus 40. Sorry, mod A is equal to 40. Therefore, current gain 40, right? Magnitude. Now, let's go to voltage gain. What is voltage gain? That is minus 400. Okay. Again, I'll explain the meaning of minus, right? But what is magnitude? AB is equal to 400. Means whatever signal you are applying here, let us say 1 millivolt peak to peak, if you apply here, you will get 400 millivolt peak to peak. Therefore, 400 times of your input signal is applied to your load. That is nothing but your voltage gain. Now, this is the time to explain little bit about the circuit operation, right? And let's see the meaning of minus. Okay. Is this over? Write down. Then after that, I'll explain the meaning of minus from voltage gain, and let's see other observations as well. Okay. Okay. Now, let me explain a little bit here, right, with respect to real current flow. Now, this is what is your base current. Okay. And this is what is your collector current. And this is what your output voltage. Okay. This is what, because I'm speaking only with respect to AC signals, but let me speak with respect to, right, let me add a little bit about the DC, and then on top of DC let me apply AC signals. Okay. Now actually the VI whatever you are having, let us say the DC circuit is not shown or the bias circuit is not shown, but strictly speaking, before applying your actual AC signal, I told you, right, the transistor should be in active region, then only it will act as an amplifier. Therefore, who is doing that? That is what is done by DC analysis. Maybe after AC analysis, I'll start DC analysis. Okay, to understand DC analysis, we need AC analysis, but the assumption in the case of AC analysis is nothing but the transistor is in active region. Then who is doing or who is taking care of keeping the transistor in active region? The DC analysis part or biasing part. Okay, that part we will see later. But let us assume that transistor is in active region. When transistor is in active region, then I'm just taking DC signals. Let us say I'm applying DC signal. Let us say this is what your DC signal, VBE, capital VBE. If I apply capital VBE before AC signal, I'm applying capital VBE. If I apply capital VBE, right, then you will get capital IB. What is the meaning of capital IB? DC current, because of DC voltage. Therefore, this is what your capital IB. Now, because of capital IB, what you get? We will get capital IC. Therefore, you will get capital IC. Because of capital IC, what you get? You will get capital VCE. This is what is capital VCE. People say, I can say the output is nothing but capital VCE. Maybe for your understanding, when I say VCC is equal to 10 volts, right? Let us say the transistor is having some beta. Then using DC equation, we know that IC is equal to beta into IB plus 1 plus beta into IC naught, right? Therefore, beta is known to you, and from input VBE, the DC voltage, we know IB. If you know IB and if you know beta, and for the time being, if you neglect the reverse saturation current, then IC is approximately equal to beta into IB. This is what is your main component. You can neglect this part. Then we know beta and we know IB. We can calculate IC because it is current controlled current source. Your output current is controlled by input current. Your input current is controlled by input voltage. That input voltage is set by your input DC voltage or using some biasing configuration. Maybe that part we will see later, but let us say we are applying DC voltage. That DC voltage is giving DC current. That DC current is giving output DC current. That output DC current is giving the drop across RC. Let us say we have chosen RC or the combination of IC into RC for DC signals. Let us say it is having 5 volt drop, then out of 10, 5 volt here, then remaining for 5 volt you see across the transistor. That is actually your output voltage 5 volt. Let me take it as 5 volt. Okay. But remember, before applying your actual AC signal, I want my output DC voltage exactly half of your rail to rail or in between rail to rail. Rail is nothing but maximum power supply what you can get is nothing but 10 volts, and minimum power supply or minimum voltage what you can get is nothing but 0 volt. I want to have voltage swing about the DC voltage. Before giving actual AC signal or the signal what you want to amplify, the circuit should be ready for the amplification. Then let us say your output DC voltage is 5, which is in between your power supply rail to rail. Maybe if you ask me whether transistor is in active region or not, if VCE is equal to 5 volts, we can check. I already told you, right? What is your VBE? Your VBE should be greater than or equal to 0.7. Yes, for DC condition. And what is VCE? VCE is equal to 5 volt, which is greater than 0.2. Therefore, definitely it is in active region. Now your circuit is ready, our transistor is ready for the amplification. Now let us apply the signal what you want to amplify. Therefore let us apply the signal whatever I want to amplify. Then let us see. Let's see the first half cycle of your sine wave. Then if input is increasing, then what about your base current? Therefore now on top of DC you have the variation. Variation in the sense signal which is changing with respect to time. That is what is our AC signal. Therefore, the black portion whatever I have written on top of the DC, which is capital VBE, which is a small VI, which is in black portion. Therefore, that is the signal which is what is changing with respect to time. The DC which is not changing with respect to time. That's why in AC analysis we don't speak about the DC quantities. We only speak about AC quantities. Doesn't matter. Little bit I'm explaining DC plus AC, which I need to explain after completing all AC as well as DC analysis part. Okay. Now I'm increasing the input current, input voltage, then definitely the base current will increase. On top of the capital IB due to capital VBE, because of the AC signal, let us say there is a current on top of capital IB which is small IB. Therefore the small IB is because of a small VI or the signal which is changing with respect to time. Then if IB is increasing by IB, your IC, let us say it is increasing by something called small IC. When the current is increasing, definitely the drop across RC also will increase. When the drop across RC is increasing, how much voltage increment across RC? Same amount of decrement you see at the transistor output, because the VCC to ground, that is what is constant. This voltage is equal to this voltage plus this voltage. If the voltage across RC is increasing, then the voltage at the output of transistor will decrease. But how much is the increment? That depends on your IC. How much is the change in IC? That depends on IB to beta. If you have beta which is in the order of 50, basically this is nothing but HFE, right? If it is 50, whatever current again you got, right? Let us say 50, then 50 times of your IB is nothing but your IC. Okay? Because I have done some approximation, therefore you are getting some beta. Therefore, now 50 times of your IB is nothing but your IC. Then whatever current you are pumping into your base, 50 times of that current is coming into the collector, then 50 times of that current is flowing through your RC, then you will get more drop, then you will see lesser drop here. Therefore, your voltage will be something like this. Here your input is increasing by small quantity, but your output is decreasing by large quantity. That is because of IC to IB relationship, because of inherent current gain, or because of current controlled current source action of your BJT. Your output current is controlled by your input current, input base current. That's why we are getting the swing something like this. Now if you see the next, the input half cycle, input is decreasing, then base current will decrease, collector current will decrease, the drop across RC will be decreasing, then the voltage at the output of transistor will increase significantly. Therefore, now if you calculate output peak to peak divided by input peak to peak is nothing but your voltage gain. Therefore, output peak to peak divided by input peak to peak, that is voltage gain. But if you see the relationship between, the phase relationship between input and output is opposite. When input is increasing, your output is decreasing. This is what is called 180 degrees phase shift for sinusoidal signals, and or you can call it as phase inversion between output to input. That the minus is indicating the direction. Direction means when input is increasing, your output will decrease. When input is decreasing, your output will increase. But remember, for a small change in input, large change in the output, that is nothing but your amplification. Therefore, but when input is increasing, your output will decrease. Only the phase is nothing but when input increases, output decreases. That is only the direction or the phase difference between input to output. Okay. and nothing to do with that minus except the phase. Then if you take the magnitude, output peak to peak divided by input peak is nothing but your voltage gain. I hope everybody understood, right? Therefore, maybe if you don't want to have this inversion also, you take one more stage. That is nothing but multi-configuration, multi-stage amplifiers. Then if you take one more stage, then what will happen? The output is input to next stage. That is also having 180 degrees phase shift for sinusoidal input, 180 degrees phase shift for sinusoidal input, 180, 180, 360 or 0 degrees, or I can say minus into minus, it will become plus, and there is no phase inversion between input to output if you take two-stage common emitter amplifier. I hope this is clear. Write down. I think I explained what is current gain. 40 times of your input current is nothing but your output current are entering into your load, and 400 times of your input voltage is applied to your load, but the minus is indicating the direction. Therefore, in the case of current gain, opposite to the load current is expected, which is entering into load, but the actual current is opposite to the load current, that's a minus. Here, your output is decreasing when input is increasing, but there is a phase relation, which is what is inversion. That's why the minus is indicating the inversion between output to input. But magnitude wise, output peak to peak divided by input peak to peak, that is what is your voltage gain. Okay, take this. Therefore, the blue color whatever I have represented here, that is what is DC quantity, and then on top of DC whatever I explained, AC quantity. Therefore, tell me, if I speak about voltage gain, output peak to peak divided by input peak to peak, I don't bother about DC quantity. Wherever this DC, let us say is 5, if it is 4, if it is 3, doesn't matter. I am speaking only output peak to peak divided by input peak to peak. When I speak about voltage gain, I don't bother about DC quantity, right? That's why we don't need DC signals. But remember that DC biasing is important to keep the Q point stability, to keep Q point stable, else you see some distortion. Okay, take it. Still the observation part is not at over. You are just observing, and then I just explained meaning of minus from current gain, meaning of minus from voltage gain, right? And 40 is the magnitude and 400 is the magnitude of voltage gain. Now we need to understand whether the voltage gain whatever we have minus 400 or current gain minus 40, they are high or low with respect to single stage configuration. Okay, that part I will explain, and then after that I'll come back to the Ri, R0, the input impedance and then output impedance significance, and then what are we looking for and why are we not getting the expected values of Ri and R0. Then we will see next set of problems. Okay, if this is over, let me stop now, and we can see maybe the video will be resumed and continued to focus on the circuit. Therefore, you can take it down, you can note it, but in the next session I'll explain the parts what I discussed now. Okay, thank you.